Hi, welcome to Common Core Algebra II. Today's lesson is 4.9, Graphs of Logarithms. Now, I know logarithm is a pretty scary word, but remember what it means. It just means it's the exponent. We're just talking about the inverse of an exponential graph function that we just cannot write any other way, so we need to use a word that represents it. So, we're going to explore some graphs today, including their construction, their domains, and their ranges. So taking a look at example 1, exercise 1, consider the logarithmic function y equals log base 3 of x and its inverse y equals 3 to the x. Construct a table of values for y equals 3 to the x and then use this to construct a table of values for the function y equals log base 3 of x. So why don't you pause the video and do that, because you don't really need a calculator to do this. All right, so pause the video and then we'll double check the answers. One ninth, 1/3, 1, 3, 9, and then of course the other way around, we're just going to flip these for the log. So my range becomes my domain, and my domain becomes my range. All right, and when we graph these, we get 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We get 1, 3. We get 1, 0, 1. And then it keeps, so this is the first one. This is our exponential, which of course is a traditional exponential. This is y equals 3 to the x. And then our inverse looks very similar to it, but it's going to be reflective over that line y equals x. So this is going to be 2, 9, which is here. This is going to be 3, 1, which is here. So this one comes this way and goes like this. So this is y equals log base 3 of x. So we graph that, label with equations, which we did, state the domain and range of y equals 3 to the x and y equals log base 3 to the x, and we can just look at our graph to determine that. So the domain of our red function, our y equals 3 to the x, is going to be basically all real numbers. Okay, now you can either, remember we talked about this, you can either do a bold R or you can write all real numbers. Okay, and the range, and if you look at the range this time is going to be positive. It's going to be above the x-axis. So the range here is going to be, let's see how we're going to write this. How about y such that y is greater than 0? Right? That makes sense. So when you talk about the domain and range of the other function, the log function, that we're just going to switch those domains, and you can see very easily if you look at the x's go from here and then keep going. So this is going to be very similar to our range. This is going to be x such that x is greater than 0, which is a very important piece of information, which means we can't take, looking at this right here, okay, there's our x. We can't take the log of a negative number. It just is not defined. All right, so the range here is going to be, again, all real numbers, because there's no limit on your upper bound and there's no limit on your lower bound. Okay, so write down what you need to there and meet me at exercise 2. So using your calculator, sketch the graph y equals log base 10 of x on the axes below. All right, so let's pull up our calculator. into your calculator, you pull up your function icon, and you're going to put in log base 10 of x. Now remember, this is a common log, so you actually don't have to put the base 10 in. So you find the log right here at the button log. See where it says over the 10 on the left-hand side? So you're going to hit Control and then this button right here, and it's going to come out log. Now you have to put the base 10 in for this case. I'm sorry, wrong one. Base 10 goes there. We're just going to delete that out. And I don't know what just happened. Let's try that again. Log base 10 of x, just like it shows in the problem. All right, so we're going to look at that and we're going to hit enter, and that's what it looks like. Now again, this doesn't help us an awful lot. It helps us more when we look at, and be careful, it looks like it hits that y-axis, but remember that y-axis is an asymptote. It doesn't actually hit it. This calculator does not show that it needs to stay off that y-axis. So be careful. So it's very important to make sure you're looking at the table. So table 7.1, split the screen, and let's take a look at what this looks like. So if you take a look at your x's, 1, 2, 3, 4, all right, it's going to get larger and larger until you finally get to, and if you bring this down, you'll see all of a sudden at 10 you're at 1. So that's a good point to use. So let's go back to our problems here and say, okay, well I know at 10 all the way over here, I'm at, now there's 2, so I'm assuming this might be 1. So at 10 I'm at 1. At 1 I'm at 0. And then we're going to get closer and closer. So basically, if you're going to sketch this, it's going to look something like this. All right, so really the only thing that you needed off of that table was the 1, 0 and the 10, 1, and then knowing that it gets closer and closer to the y-axis. Now the domain here is going to be your x value. So it's going to be x is greater than 0, just like before. So x such that x is greater than 0. And my range is going to be all real numbers. So there's a few ways we can write this, of course. All real numbers. Some like to do this. Negative infinity is less than y is less than positive infinity. So, or you can even use your interval notation, negative infinity, positive infinity, like that. So if it doesn't tell you how to represent it, you can use any way you want to. All right? So moving on to exercise 3. Which of the following equations describes the graph shown below? Show or explain how you made your choice. Well, the easiest way to do this, especially if it's multiple choice, is to put all of these into your calculator. All right, so if you put these into your calculator, you can see the points that they give us here. So you know that points like this point right here is the point negative 1, 0. That's on our graph. This point right here is 1, 1. That point is on our graph. The point negative 2, negative 1 is on our graph. So my suggestion here would be put these into your calculator and see which one this mimics. And if you did that, and of course you don't have your calculator at home, so we're not going to spend an awful lot of time on this one, but that's the problem that it is right there, that equation. Okay, so the fact that finding the logarithm of a non-positive number is not possible in the real number system allows us to find the domains of a variety of logarithmic functions. All right, again, there's that same situation. This right here, even though here we do have x's that are negative, because we're adding 3 here, it actually is going to shift the values over to the right to make the actual logarithm positive. Okay? So moving on. Oops, where is 4? Here it is. Determine the domain of the function y equals log base 2, 3x minus 4, and state your answer in set builder notation. So here it tells us, All right? So basically, since we can only take the log of a positive number, what does this tell us? It tells us 2 to the what power has to equal 3x minus 4. I always translate things. It makes it easier for me. Okay? So we know in this case, we know that that exponent, all right, or we know actually that this 3x minus 4 has to be greater than or equal to 0. So that's the information that's helpful to us. So we have 3x minus 4, and we know that has to be greater than 0. Can't be 0. Okay, nothing raised to the anything power is going to give you 0. So it can't be 0, it can't be negative. So add 4 to both sides, and you get 3x is greater than 4. Divide both sides by 3, and x is greater than 4/3. So this is telling us to put it into set builder notation. So domain would be x such that x has to be greater than 4/3. There's your set builder notation. Okay, going on to exercise 5, which is our last exercise. Moving on. So all logarithms with bases larger than 1 are always increasing. This increasing nature can be seen by calculating their average rate of change. So again, here we go, bringing other things into our new work that we've already covered. So consider the common log, or log base 10, which is f of x equals log of x. Remember, if there's no base there, we're assuming it's base 10. So set up and evaluate an expression for the average rate of change over the interval from 1 to 10. So just like before, we have to figure out, we have our x values. We know this is 1 something. We know this is 10 something. We need to find those y values associated with our x values. So what is log base 10 of 1? Well, what does this tell me? This means 10 to the what power is equal to 1. Well, of course, we know that's 0, because anything to the 0 power is equal to 1. So this one we're going to rewrite too. This is 10 to the what power is equal, you're right, base 10 to what power is equal to 10, and of course this one's going to be 1. So there are your 2 points. All right, so now you're just going to find the change in y over the change in x. All right, so change in y. So it's going to be 1 minus 0 over 10 minus 1, which is equal to 1 over 9. So there is my average rate of change. B says set up and evaluate an expression for the average rate of change over the interval between 1 and 100. Well, the first one we still remember. That's going to be 1 comma 0. And if you have 100, 10 to the what power gives me 100? And the answer, of course, is 2. So let's do the average rate of change here. Change in y is going to be 2 minus 0 over change in x, which is 100 minus 1, which is 2 over 99. So then, what do these two answers tell you about the changing slope of this function? All right, well, obviously, as x gets larger, we can say as x gets larger, it's asking about the slope. What happens to the slope? The slope becomes smaller. What does that mean in terms of the graph? Okay, this means, make sure you're communicating this like the person you're talking to doesn't understand. This means the curve of the line becomes more horizontal. Or you could use the word flatter. Again, one more time, I'm going to remind you, it's about communicating. Using academic vocabulary is always preferred, but if you can't think of the words or the words just don't come to you, just make sure you're communicating the right information that the question is asking. All right? So that's it for 4.9. Um, we're going to be moving on to 4.10 shortly. So until then, make good choices, and I'll see you next time. Bye.